Alright guys, we are back for another video. We've got Kate back here taking the test. Say hi, Kate.
Hey guys.
Okay, so anyway, Taneem, say hi.
Hi.
Anyway, I didn't want to be rude and leave them out of this, but anyway, before you take notes on this, you're going to hear a lot of people coming in and out of my room because we're getting ready to have an SAT class here. I want you to go to assignments on your ed line, and under assignments you're going to see something called student notes proving trigonometric identities, and I want you to go ahead and grab that because this sheet of paper has got a lot of hints on some things that you might try when you're doing proofs and you get stuck. Alright, so let's go ahead and take a look at a few examples here, and I'm going to do a proof. I'm going to show you what you're going to need to do these proofs. Proofs are not like what you're used to in geometry. With proofs, your work is your proof. And so what we have to do here is we are going to pick one side to work on. You may not work on both sides of the equal sign. In other words, you can't work with one for a while and go to the other side and work with one until they match. When you prove something, you have to start with one side and make it look like the other side. And you're going to see on those hints that you should have pulled up from your assignments that you should probably start with what looks like the most complicated and break it down. That's typically easier. I'm going to do this first proof two different ways, and I encourage you to be creative with these. There is not one approach to most of these. Most of these have separate answers. As long as you do correct substitutions and you get to the right answer, then you've done it correctly. So I'm going to do this first one here. I've got to prove this identity, and obviously the left-hand side looks a lot more difficult than the right-hand side. I'm going to do this first one by rewriting this as secant squared x minus sine squared x over cosine squared x, because secant squared is 1 over cosine squared. And then what I have here is sine squared over cosine squared. That is an identity. Well, that is tangent squared. So I'm going to have secant squared x minus tangent squared x. And you should know from your Pythagorean identities that tangent squared x plus 1 is equal to secant squared x. So if you subtracted tangent squared from both sides here, you would get the statement that 1 is equal to secant squared minus tangent squared. So since we got here in two steps, this is equal to 1, and I have proven that. And that's not the only approach. I could have, big fat or here, I could have factored this. This has two terms, and they have a common factor of secant squared. So I could have factored out a secant squared, which would have left me 1 minus sine squared. And you should have seen yesterday that this happened a lot. From cosine squared x plus sine squared x, from that Pythagorean identity that equals 1, then 1 minus sine squared is equal to cosine squared. And we have secant squared, which is the reciprocal of cosine squared. So that's 1 over cosine squared times cosine squared, and those cancel, and we also get 1. So I've done this two different ways. Here I just substitute something in and use Pythagorean identity. Here I factored and used Pythagorean identity. Either way, as long as you do a correct substitution or a correct formula and you get to the right answer, then you've done it correctly. Oh, and Zaheen just walked in. Zaheen, say hi to everybody.
Hi.
Say it louder.
Hi.
Okay, that was Zaheen. She's on our video now. Okay, second one. We're going to do 1 plus 2 tangent squared equals secant to the fourth minus tangent to the fourth. And I think that the right-hand side looks the most complicated here. So I am going to start with the right-hand side, and I am going to factor. This is a difference of squares. That is secant squared x minus tangent squared x times secant squared x plus tangent squared x. You can multiply those back through if you don't believe that. So here I just saw from the previous example that secant squared minus tangent squared, well, that's equal to 1. And we want to keep our eye on the ball here. We want to keep our eye on where we're headed. We're headed to try and turn this into 1 plus 2 tangent squared. So from here I might try and substitute for the secant squared so that I'll just have tangent squareds in my statement. And we should know that secant squared is equal to tangent squared plus 1. That's one of our Pythagorean identities that we've used a lot. And we substitute that in, and looky here, 1 tangent squared plus 1 tangent squared is 2 tangent squareds. So we've made it into 1 plus 2 tangent squared of x. We work with one side until we make it look like the other side. And here, factoring was really the most elegant way to approach that, in my opinion. All right, let's look at another one. Another one, you can see the left-hand side looks like the most difficult one. And so I've got cosecant times cosine squared plus sine x. So let's take a look at this one. Cosecant can be rewritten as 1 over sine. And of course, cosine squared is just cosine squared. I'm going to put a 1 underneath that. And then plus sine of x. All right, and then I'm going to bring these fractions together because we're multiplying. So that's cosine squared x over sine plus sine x over 1. And here I have two fractions. Yesterday when we had two fractions, we saw we wanted to bring those together, and you can either make common denominators or you can crisscross multiply. I showed a lot of you this yesterday. You multiply this times this, which is cosine squared, and then you multiply this times this, which is sine squared, and then you multiply the bottoms together. That's a quick way of adding two fractions. And boy, oh boy, you've got to learn this first identity. Cosine squared plus sine squared. Everything is based on that. That is equal to 1. And 1 over sine x is equal to cosecant x. So we have proven that. Okay, so here is an approach that we haven't seen before, and well, we've seen it, but I don't think we saw it with trig like this. And anytime you have two terms in a denominator, this obviously looks like the more complicated side, we are going to multiply the top and bottom by a clever form of 1. And that clever form of 1, oh no, there's announcements. Hold on one second. I'm going to pause this for just a second.